Warm welcome to all who decided to spend next hour with us. This is the first one in the series of Alfa Laval webinars organized for brewery customers from Poland, Baltic states, Ukraine and Romania, which will provide you with the information on the processes and applications related to our products. Today, our guest speakers, Denis Martin and Yarim Grado from Alfa Laval Central Organization in Denmark, will walk through details of the dry hopping with use of Alfa Laval solutions. After presentation, we invite you to Q&A session. We encourage you to type your questions in the chat box during webinar. Now, considering value of each minute, let me already hand over to our first guest, Mr. Denis Martin. The floor is yours.
Thank you, Maciek. So my name is Denis Martin. I'm the regional sales manager in brewery system teams, sitting in Alfa Laval Copenhagen. And some of my regions are the Baltic countries, Ukraine, and Poland. So today I will present you one of the two Alfa Laval solutions we have for dry hopping, and this is the IMXD, we call it. So before going directly into the product and the details of the product, let's have a quick look at what is dry hopping. So dry hopping is basically the addition of hops into the beer at a later stage. So hops are usually added at the end of the fermentation when we do dry hopping. But it can also be done at the start or during fermentation. And the goal of this later hop addition is to get the fine and volatile essential oils from the hops to add that particular aroma profile to the beer. And usually those essential oils are lost when you add them in the brew house. So one of the most known dry hop beer styles are the IPAs, right? You have session IPAs, New England IPAs, etc. So on the picture here, you can see a very old way to dry hop. It's basically hop flowers in a bag, and then you would put the whole bag in a maturation vessel, wait for a few days for the extraction process to happen. And then once you would reach your aroma profile, you would empty your tank. The hops would stay in the bag. But there was quite a few disadvantages to that. And then furthermore, the breweries have now moved to other hop products. So most of the breweries, when they do dry hopping, they're using hop pellets. But that's also coming with a few disadvantages. Of course, there is the advantage that they are very compressed, they're dry, they're powdered, they're easy to handle, but they're also very dry. The hop pellets contain around 90 and 98% dry solid content. So they will bring a better yield and it will be easier to use them in the brewery, but there will be also a few challenges coming up, and we will have a look at those few challenges. So for example, the first thing that is related to their very high dry solid content is that as soon as they are in contact with the liquid, they will start soaking up a lot of this liquid. So we did a very basic test here. You can see on the left side of the slide that we put hop pellets in some bags, and we let them sit in water. And then a few hours later, you can see that those bags on the right have actually got actually bigger, right? So all the hop pellets started expanding in that bag. So first, there is a lot of beer that went into those pellets. And then second, there is an expansion. And if we now open those bags and see how the pellets are looking like, you can see that it's not fully disaggregated either. The pellets are actually quite dry still. If you think that they have been actually soaking in a liquid and we open them now, it's very dry. You can also imagine that the extraction process of those oils is very poor as well, since all the hop pellets that are in the center of that bag have a very low availability, a very low contact with the beer. they're in contact with. That's one problem with the expansion of the pellets. Now imagine that you don't use a bag and then you put your hops directly in the tank. If you're not careful and you put your hop pellets in your system, in your tank, through a line, for example, and you forget to flush your line correctly, if some pellets are staying in the line, they will expand as well. But if the volume is not large enough for those pellets to expand, they will form some sort of very hard paste, and it looks almost like a green concrete. If the line is long enough, it's almost impossible to get rid of those hops into that line. And most probably you will actually have to almost cut and replace your line in order to get rid of the issue. Those are the problems and the risk related to the expansion of those hop pellets. Now there is another issue, is the behavior of those hop particles once they have been disaggregated in the beer. So in the brewing industry, we're very used to particles that are sedimenting, right? We are used to yeast, we know how to sediment them, we know how to treat the bottom of a tank cone. Now with hop pellets, it's actually not guaranteed that all the hops will sediment like yeast. Some of the hop particles will sediment, and some of the hop particles will actually float. You can see that on the right picture here. We have just disaggregated some hop pellets in a small volume, and some of the pellets will float to the surface. And this is, again, difficult to predict. We have seen that actually some hop varieties will all sediment, some hop varieties will mostly float, and some other ones, of course, will be in the middle. Some will sediment, some will float. So if we go at the larger scale in a bigger brewery, let's say in this case, for example, a customer before installing an IMXD was putting all their pellets loose in their tank, they would purge the first amount of pellets out of the cone directly to the drain. They would process the beer afterwards. On the left side here, the first picture on the left side, you have the beer that is very clear, right? So you can see that it's very easy to process. We send the beer to the separator. We have purged the first hops. There is no problem for the separator to treat that beer. And then the beer is further sent to the cross-flow filter in that case, or the filter in this case. Near the end of the filtration, when there is only a few % left in the tank, you can see that the part of the hop pellets that normally float are being sent to the separator. But this means a huge variations in terms of solid concentration for the separator. And any separator will have a very hard time to deal with such a variation, drastic variation in solid content coming on its inlet. And then unfortunately for that customer, it was impossible to predict, let's say, accurately when those floating hop pellets would come. And on top of that, when it happens, it's very difficult to deal with the issue. So usually what would happen is that the hops would go through the separator all of a sudden. The PID regulation is not fast enough to handle that solid content. And then you would have some hops that would actually still go through the separator. Those hops that go through the separator can then lead to other process issues, such as, for example, clogging the inlet of a plate exchanger. It can also happen to have hop particles ending in the beer filter. In order to address those process issues, we've been working on the IMXD, and here is a quick presentation of the IMXD system. On the left, you can see an IMXD that is being installed in a maturation or fermentation tank. IMXD stands for Isomix External Drive. So if you are already familiar with Isomix, it's basically a modified Isomix system that will allow the repumping of much larger particles. We are able to actually handle whole hop pellets through our IMXD. So it is to be installed in a tank where the fermentation or maturation will occur, and we will require a recirculation loop. So we install a recirculation loop dedicated for that tank, and then once the hops are introduced into the tank, we start a recirculation, which will basically guarantee the homogenization and the correct disaggregation of the hop pellets into the beer. If you had to install several of these IMXDs into your cellar, you would then have to put an IMXD in each of the tanks, but then you could use, for example, one common line to introduce the hop pellets. The IMXD is also agnostic to the way you actually bring the hops into the tank. So you can bring them whole directly into the tank by pneumatic transport, but you can also bring them through a maceration tank that we call. So that is what we would recommend usually. So we would have a dedicated tank where we disaggregate the hop pellets in a concentrated way, you can say, 10% solid content. And then we would pump that hop slurry to the tank to be dry hopped. And then after the transfer has been done, we recirculate internally into the tank. Now, as soon as we talk about moving the beer together with the hop pellets, let's say as soon as there is a movement in the tank or between the hops, you can say, and the beer, we talk about dynamic dry hopping compared to static dry hopping, which is basically the very traditional method of dry hopping where you would just put the hops into the tank and wait for the extraction process to happen. There is very little difference between dynamic dry hopping and static dry hopping when it comes to aroma profile. Here you can see on the left the difference in different aromas between dynamic and traditional dry hopping. But there are also a lot of advantages. The advantage, of course, is the yield. We will have normally a better yield compared to at least dry hopping in bags. As we saw earlier, there is much more surface of exchange between the hops and the beer. And then because it's dynamic, we will reach the aroma profile we want to reach in a matter of hours instead of days. So here on this slide, you can actually see on the blue trend here is the concentration of hop aromas over time. And you can see that after 6 to 8 hours, you're already at a very high concentration. If you look at the orange line here, the orange curve is basically what you would need to wait for your aroma profile to reach what you want, and that would take a few days basically. So this first customer was trending this, and then the traditional way he would have to wait for 3 days to reach his aroma profile, and with the IMXD, you would just need to wait for 6 to 8 hours. So after you've reached your aroma profile, the second step is, of course, to remove your hops out of your beer. And then as we saw earlier, the issue is that when you have your hops in the tank and you don't homogenize, you have a lot of hop sedimenting and another part that is floating. Now, with the IMXD, since you can make it run continuously, and it will ensure that the hops are homogeneous in the whole volume, when you empty your tank and send the beer to the separator, you will keep the IMXD running. And that will ensure that the solid content on the separator inlet will also be constant. And that is a good thing for the separator. A separator that is well sized, of course, will have no issue removing all those hops and yeast from the beer. And the pictures here are actually showing the solid load at that customer on the inlet of the separator when using the IMXD. You can see that there is, of course, a solid load, but the solid load is constant over time. So from the start to the beginning to the end of the processing of that tank, there is no more difference between the cone, the middle of the tank, and the end of the tank. So we don't have this issue of carrying or sending a very highly concentrated in terms of solids beer to the separator at the end of the process. It means we don't carry over hops through the separator, and then we solve the risk of issues of clogging different types of equipment after the separator. When you remove your hops with a separator, you're also much more efficient in terms of beer losses. So you can see here on the left picture the outlets on the separator where all the hops and yeast are coming out. It is quite a solid we actually now start spraying a bit of water in the cyclone so that it's easier to handle and easier to pump in another waste tank. You can also see here how it is pre and post centrifuge. There is quite some solid, again, homogenized on the inlet, but on the outlet there is absolutely nothing. There is no carryover after the separator, and that is what, of course, is important here. And if we compare two brands that have been dry hopped with the IMXD with the former technique, that brewery was usually using 5 to 7 days with the first brand. They could reduce those 7 days into 1 to 1.5 days now of process time. And then they could also reduce their beer losses from 10 to 2% losses. And then the other brand where they were using more hops and had to wait up to almost 2 weeks, up to 10 days, they reduced that process time to, again, 1.5 days. So after 1.5 days, they were done with their dry hopped beer. That is also including the introduction of the hop pellets into the beer, but also the removal of the hops, so the centrifugation process. And again, here they had up to 15% losses in terms of beer loss, of product losses, and then they reduced those 15% to 2 to 3% product losses, which is quite a big reduction. So here we can see a bit more practically how the system looks like and what are the requirements. It is thought to be put in larger beer tanks. It can be put, we say it can start in tanks that are around 150 hectoliters, but that's very much on the low side, and it can go up to 5,000 hectoliters tanks. Hop dosing rates can go up to 15 grams a liter, or it's 1.5 kilos per hectoliter. If you need even higher hop dosages, you can, of course, contact us and we can see what is possible. There are some limitations, though. In order to install this, we need a swing cone and we need some clearance under these tanks. So we need at least 1 meter of clearance to be able to install the system. And then we do recommend, indeed, as we just saw, to remove the hops with the separator. Even though if you don't have a separator and still interested in that system, then you would just have to wait for the sedimentation of the hops and then do a traditional purge of the hop pellets. To summarize, what the IMXD offers is basically a solution for larger breweries to dry hop very large volumes and to make sure that we reduce the process issues related to the disaggregation of the hop pellets and the expansion of the hop pellets in small confined places, but also the removal and then the reduction of the product losses. There is a smaller waste stream. There's complete hop removal when we use it with a separator. There is a very fast and efficient aroma and flavor extraction. The product flavor is usually matching. And then we can do very large batches with this technique. Additional benefits are the same as what our traditional isomix brings in a fermentation tank, because of course what the IMXD does with the hop pellets is one thing, but can also keep the yeast homogeneous during the whole fermentation process. So it's interesting also for breweries who want to optimize their fermentation processes to have it's a two-in-one solution, you can say. But that was it for the IMXD. I will now leave the space to my colleague Harim. Thank you for your attention.
All right. So, hello everybody. My name is Harim Guajardo. I am also located in the office in Denmark. I work as a global product manager, taking care of the solutions for craft brewers mainly, but I'm also the manager for the other dry hopping solution we have, and we will talk about it now. It's what we call Alhop. All right, so let's start with this system. So Alhop, as it is, it's a stand-alone module or a skid mounting system. The idea of the system is that we should be able to introduce the hop pellets. Instead of doing that in the fermentation maturation tank, we do it on a smaller tank that is just located in a different place in the brewery, near the tanks, let's say, in the fermentation area. And we can do it for different capacities. Important to mention that Alhop was developed for craft brewers initially. So the capacities are different because the idea is that, or normally they have smaller tanks in craft breweries, right? So we can handle 50 batches of 50 kilos, 100 and 200 kilos of hop pellets per batch. And we are actually just recently develop a new size that it's good enough for 500 kilograms of hops. Same as my colleague Denis mentioned, the idea of doing this dry hopping as dynamic dry hopping is to be able to be more efficient with the times, production times, and get more yield. So instead of waiting 2-3 days as the traditional methods, which is as Denis showed, just to introduce the hop pellets in the fermentation tank and wait. Here we will do it dynamically, and we are also talking about reducing the dry hopping time to 2 hours. It's a little bit depending on the volume of the fermentation tank. And yeah, one of the main advantages, as I already said, it is that we will keep the hops out of the fermentation tanks. Let's have a closer look of some of the main components of the system. Most important component in our system, it is the filter. We have a filter that it's made out of wedge wires. After talking to different hop suppliers, we realized that the separation that we needed to be sure that we will not introduce hops into the fermentation tanks, it will be around 100 microns. According to the hop suppliers, normally we can have particles of around 200 microns. So we went to 100 microns to be sure that we will not let through the hop particles into the fermentation tanks. Besides the filter, we have the standalone tank, as you can see in this very schematic diagram. And then we have 2 pumps. The inlet pump, which is just a centrifugal pump that is connecting to the tank that we want to dry hop. And then we have what we call an SRU pump. It's a lobe pump, positive displacement pump. This pump will be recirculating the hop slurry that we will prepare in this system, right? We have 4 main steps in dry hopping. So we talk about hop addition as the first step. Then we talk about disaggregation as our second step, which is basically, put the beer and the hops in contact. So the hops they're not dissolved, but they are basically, forming this slurry. Then we have the extraction process, which is mainly get the aromas and flavors we want from the hops. And finally, we have hop removal, which is taking care of the leftovers of hops, right? So this is how the system looks a little bit more in detail. From left to right, we have the product inlet. It is connected to a centrifugal pump. Then we have the recirculation pump. As I mentioned before, this is the positive displacement pump. We have the connection to the source tank. So when we are recirculating, we connect the product inlet to that tank, and that tank needs to feed it, or it needs to have a second entry point, right? So we can recirculate. We can also see a close-up of how the wedge wire looked inside the filter. The way we add hops into the tank, it's we do it manually. We have the possibility to just remove a blind connection here and just put this funnel, so we can introduce the hops at once at the beginning. And since we want to keep this process free of oxygen all the time, we have a CO2 inlet that will allow us to purge air from the empty tank, and after we introduce the hop pellets. Besides adding the hops into the tank, which is has to be done manually, all the process that I'm and the equipment we have, it is working automatically. Let's now go to the first step of dry hopping. Right, we have the hop addition, and we will start from a clean system, clean tank. This means that it has been CIP'd, and of course this is also working automatically. So we will remove the blind and put the funnel in. Before doing that, we will push with CO2. We will fill the tank and the system a couple of times and exhaust to remove the oxygen or that is already present in the system. So we do that once. Then we introduce the hops we need into the tank, depending on the recipe you have for your dry hop beer. And then we close, we take out the funnel, we put the blind again, we introduce CO2 again to remove what's remaining on the. We now go for the step of disaggregation. What we do here is we start introducing beer from the product inlet with the centrifuge pump. We go through the SRG pump from the bottom of the tank. And then what we do is we start lifting the pellets with beer. And as we start doing that, we have the exhaust line open to remove whatever is left of this mixture of CO2 and air. So as soon as we start filling the tank, we start exhausting what we have there, right? And the tank, we should see this tank as a pipe, let's say. There's no head space. The tank will be completely full. The idea is to do it like this to avoid having a free space for unwanted oxygen. So we will fill the whole system with fresh beer, and we will start recirculating using the SRU pump. This process can take, it takes about 10 to 15 minutes. We normally say that, but as soon as we introduce the beer into the tank, into the Alhop tank, we can already talk about that this aggregation started. After we finish doing this recirculation internally, we go to the extraction step. In this step, the idea is to recirculate beer from the tank that we want to dry hop. Okay, in this case, it's always a little bit about what the brewer wants in terms of aromas and flavors, right? But we have, as a rule of thumb, more or less, that we would like to recirculate twice as much the volume of the source tank to say that the beer has been dry hopped. So to give a very simple example, a fermentation tank of 100 hectoliters, if we recirculate at a rate of 100 hectoliters an hour, we can say that after 2 hours, the beer is more or less dry hop. As mentioned already, whenever we are doing commissioning, times are adjusted on site depending on the results. It can be a little bit more, or it can be even a little bit less. When we do this, then when we're doing the extraction, it's then we keep the product inlet open. We also keep the product outlet open at all times, and going through the tank, we start recirculating the hop slurry. In the filter, we have, as mentioned before, the cross flow effect because we will have the centrifuge pump on, and then we will. This is how we will be extracting the aromas and the flavors all the time, introducing this fresh beer from the source tank, going through the filter. In traditional methods, then somebody needs to go to the fermentation tank and check if the hops are not just floating around, or if you don't have a centrifuge, or remove this bags with hops from there. since we already have the hops outside of the fermentation tank, this is basically already done. We don't have to worry about removing the hops from our system. And I'm talking about the fermentation tanks and the process that it's after that, right? So we keep the hops here, and it's only a matter of removing the hops via the drain at the bottom of the tank. After that, something that it's making Alhop different from other modules or solutions is that we are actually able to recuperate beer afterwards. We have two different steps for this concentration step and a diafiltration step that will require deaerated water. But let's first talk about the concentration step. What we do is when we stop introducing beer from the source tank, and we only keep open the outlet. Then using the CO2 connection we have, we start pushing from the top, or let's say squeezing the hop slurry we have in the tank. This pump has the possibility to work in the other direction, because that's how we have it we have the connections in the panel and the automation, and the pump can run both directions. So in this case, we start running the pump in the opposite direction. Then we squeeze, as I mentioned, from the top, and then we start recovering beer from this hop slurry. This beer, it's super concentrated hop. It contains a lot of aromas and flavors in this beer. So we will do this until we reach about 14-15% dry solids content in this slurry. This is because more than this, then it's really hard for the pump and the system to move around this slurry. It's quite thick at this point. So then we can basically say here that we have finished with the concentration step. If in your brewery you have the possibility, or you have access to deaerated water, and you don't mind lowering the plateau in your fermentation tank a little bit, you can then introduce some deaerated water into the system to dilute a little bit, let's say, the slurry. And then we will basically just repeat the same concentration step as we had before. We will start pushing again, and until we reach approximately, again, 15% concentration. That's it for the process of dry hopping in our Alhop. In this slide, I'm showing a little bit. In the picture, you can see how it looks. The hop slurry, it's as I mentioned, it's really thick. In this was a test we had recently. Actually, it was beginning of this year in a brewery in France, and after that, the results were that the concentration in this hop slurry was 50% dry solids. And we actually have a very, very short video to show how it looks when we are removing it from there. So I will let you have a look at it. Yes, as you could see on the video, it is very, very dry and thick slurry that we got at the end after concentrating. So just a short summary of the different sizes. As I mentioned, we have 4 sizes. So we name our system by the amount of maximum kilograms of hops we can take in each batch, right? So we have Alhop 50, 100, 200, and 500, which is for 50, 100, 200, and 500 kilograms. The size of the tank for each module, it's basically a relation of 1/10 the amount of hops we can have, right? So as you can see, for Alhop 500, the tank size will be 10 hectoliters. So it's not really, it doesn't take a lot of space in the brewery. It's a small tank. And the main difference it is related to the number of filters we need in each module. Both for Alhop 500 and 100, we only need one filter. For Alhop 200, we need 2 filters, so we have enough filtration surface. And for Alhop 500, we're talking about 4 filters. These filters are not something that you need to change within time. They're not consumable, so it's just stainless steel. So you can keep those filters working without any problem. And this is just a very quick, this slide is just to show we worked together with the BLB in Berlin to develop this module. And back then, we, with the help of one craft brewer in Berlin that let us use their beer for these trials, we compare against other known application of dry hopping, which is the very popular hop gun. And as you can see in this diagram, it is the results are very similar in terms of what you can expect of this dry hopping, right? This was a good result, right? We were comparing against this other competitor, and yeah, you can see that we have very similar results in terms of flavors and how quality of the beer, how it looks. So this was really good. We actually have the full report available from BLB, and we can just share with whoever is interested. We can just share it via email afterwards, and you can have a closer look of all the results. Yeah, finally, just a little bit of references from other projects. We have for different type of in different breweries, let's say both bigger groups and independent breweries. We also have available rental units that we have been moving around. Last year, we during the second part of the year, we used the rental unit in 2 different breweries here in Europe. Now we're sending it to USA, and we should be able to have this rental unit again back during Q3 of this year. And yes, that is it. So now we go back to Maciek and to see if we have any questions to answer. So please, Maciek.
So the first question: does Alhop also work for infusing of other ingredients such as vanilla, cacao, nibs, and other peelable ingredients?
Yeah, so even though we developed the module for hop pellets, we have had this request before, actually, this question, and we think that we can do it in a simple way. We should be able to just have something inside the tank where people can just hook a bag with the ingredients such as they mentioned here, cacao nibs or things like this. So I think we can make it to work. But in cases like this, since there's so many ingredients that we can talk about, it's recommended that maybe we can have individual meetings to talk about the ingredients and how can we accommodate these requests.
Okay, thank you, Harim. The second question: are there any plans to extend the second solution? It means Alhop to the bigger volumes, like 300, 500 kgs of hops.
Yes, it is like that. We have now the biggest one we have is 200, but we are actually I mentioned we have developed one for 500 kilos, and that's actually we already have the design, and we already have a couple of customers aligned that they're looking at this solution with the 500 kilos. Mm-hmm.
Okay, thank you. The next question, actually, it is not specifically described to which equipment is related, but the question is, have there also been any trials with more concentrated hop pallets such as T45, Lupamax, Creo, etc.?
If it's related to the IMXD, that should not be a big issue. If it's related to the Alhop, we know a customer in Germany uses a blend of T90, T45 without issue. I think up to 30% T45 and then 70% T90. And he was successful with that. We tried with Cryo, much higher content. And here the dry hopping was successful as well, with the Alhop, I mean here. Huh? But then the concentration step was more complicated because these products are very sticky and most probably reduces the filtrability, even though the Alhop is based on cross flow that prevents clogging. Here the flows were quite low. But for the customer, it was not let's say showstopper, because we could maybe accommodate less or maybe fill up the system to the max, and then the beer losses would still be quite very acceptable compared to traditional dry hopping solutions.
Okay, thank you. The next question is related to the investment. So what is the more or less investment cost of Alhops?
Depending, of course, on the size and if it's the Alpha 50 or 500, it is also a little bit depending on some optionals that we have available. So maybe just to give a super rough estimation, 170,000 for an Alpha 100 as an example, fully automated, as shown in the modules. All right.
Okay, thank you. The next question, actually, I'm not crystal clear what is but the question is, example in the system of parallel Alhop vessel in one skid. So
I can see that it was maybe related to a previous question, parallel Alhop vessels in one skid, and it was, are there any plans to extend the second solution to bigger volume? So yes, we don't need to put two smaller systems in parallel. We have bigger systems up to 500 kilos. If only 300 kilos are required, we can also do something about that. But it is not necessary to put two small ones in parallel, even though it could bring actually some flexibility as well.
How does the purging the tank in Alhop work? Is it automatic or does it need manual hopping up and purging?
As it is now, we're talking about after concentration step. As you saw in the video, what we did, it was just we connected a hose and we were pushing with CO2 from the top, and then we were going into this IBC container. So it can easily can be done like that. But for the bigger system we have developed, we actually included an option with an extra lob pump with an SRU to automatically remove the hops from the bottom of the tank. So that option is actually available as well now.
Do I understand correctly? The losses for traditional dry hopping covered both cold trap and hope, while for Isomix, the cold trap loss was excluded. If so, what would be the actual difference?
Yeah, so if we strictly look at the numbers that were related to the IMXD, you can say it's for the whole thing. So they look at basically what is the final volume of the beer that has been dry hopped, and that's how they counted their beer losses. So how much did they start with before dry hopping? Let's say they have a certain amount of hectoliters in their tank, and then how much final beer do they have after filtration? This is how they looked at their beer losses and calculated the percentage losses. And then after switching to IMXD, basically, essentially what happened is that they started homogenizing and then take all the solids out, yeast and the remaining yeast, of course, because this is dry hopping during the maturation phase, so most of the yeast already has been taken away. But then all the hops were actually taken out via the separator, and then there is a massive reduction in beer losses. But again, the same way, the losses were calculated the same way. What is the starting volume before dry hopping, and what is the final beer after the filter? That's how it was being compared. So I hope this answers your question. Or in other words, we did not remove the yeast before using or leave the yeast when we were not using the IMXD, and then we will remove both of them at the same time and then change the process when using the IMXD. So most of the yeast was taken away before. So it's very much comparable. You know, beer losses are very high in terms of when we do dry hopping and we don't remove the hops via separation, or if we don't use an Alhop, because it soaks up so much beer. But as soon as we use a separator, or we can concentrate the slurry with an Alhop, then of course the beer losses are decreasing drastically. It's not much about the cold trap or the yeast and so on.
Okay, we have next question. Does the IMXD system not counteract the colloidal stabilization by moving up the cold trap, so the trap removal before filtration would be less efficient? Denis?
We haven't seen an issue at our customers in terms of haze, let's say, after the filter. On the contrary, actually, the filtration runs usually were better because there was no carryover of hops in the filter, which was much more detrimental to the runs, at least. Now, when we talk about colloidal stability on a very long term, I must say I don't know if it's related to moving the homogenization. Now, there is something that is known as well. As soon as you dry hop, you reintroduce polyphenols from your hops. And normally we all know we put the hops in the brew house, and then we introduce polyphenols from the hops in the wort during the boiling. Those polyphenols will react with the proteins, of course, and we will create a hot trap. When we do dry hopping, we reintroduce polyphenols, actually in large dose, because the amount of hops we use during dry hopping is much higher than what we put in the brew house, at least for heavily dry hopped beers. It means that the free proteins in the beer will react with those newly introduced polyphenols. So it will increase the haze. We have had customers, for example, that used to do dry hopping in BBTs, very traditionally in bags. So yield was very low, no mixing, and it was somehow not much affecting their brightness. But as soon as they tried a dynamic dry hopping system, meaning basically enhancing the extraction of the aromas, and also through that the polyphenols of those hot pellets, immediately after a few hours, you will see a haze forming again. So they had to refilter the beer. And that is most probably why it is very much recommended always to dry hop before filtration. It's actually not a very good idea to dry hop in BBTs. It's the only time we heard that someone did that. And they realized also their mistake, and I believe they have changed their plans. So in terms of colloidal stability, you have to take that into consideration. It's not only about moving, whether it's IMXD, whether it's Alhop, whether it's any other technology that will trigger a movement or accelerate the dry hopping because there is a movement, there is a mixing. It's about the fact that you will reintroduce those polyphenols that will react with the existing proteins in the beer and then might increase the haze. But normally, if you have a filter that is working properly, that should not be an issue. Especially if you have a separator. If it's a cross-flow filter, it should not be a problem. If it's a how do you call it, a Kieselguhr filter, it should not be a big issue either. I hope that answers.
Okay, we have one more question. Can you also deliver an automatic dosing system for Hope pallets to reduce the manual work?
Actually, we for this Alpha 500, we designed. We included a screw conveyor that can be considered as one of the options for the module, because it is quite a lot of kilograms of hops, right? So it is convenient to have something to make it easier. Still, somebody needs to put the hops into the actual conveyor, but then the conveyor will do the heavy lifting, let's say. So we have that as an option as well, available now for the big system.
Thank you. So, conscious of time limits, we close with this answer. Thank you all for your attention and fruitful Q&A session. Now wrapping up, as mentioned at the beginning of our meeting, please stay tuned as you will have opportunity to meet with us again on the next webinar. So thank you for all participants, for our dear presenters. Stay tuned. Bye.